So in the last Combinatorics video, we learned how to count paths on a grid using Combinatorics. In this video, we're going to manipulate this problem a little bit. So let's just get started. So we have a point C here. Of course, we have point B and point A. And we know that there are 15 paths to get from A to B. Now, what if we want to count how many of these paths pass through point C? Now, what we're going to do here is, first off, we want to see how we can break this problem up into two separate pieces. So there are two parts of this problem, really, if we take a look at it. First, we have to get from A to C. That's goal one, is to get from A to C. And goal two is to get from C to B. And then, obviously, we know in counting, we multiply. So, so if you don't understand this, we're going to go to a simpler problem. And that's what I always like to do in counting problems, is to look at the smaller problem. So if we look at a 2 by 2 square, we know that this, if we get from point A to point B, from A to B, we go down 1, 2, and we go to the right 1, 1, 2. So that's 4 choose 2, which is 6. But now, what if we want to do the same problem? We have a point C, and we have to stay on the grid. So in this problem, well, first we're going to try to go from A to C. So to get from A to C, well, this is just a square, so there's two ways we can do that. And to get from C to B, we have 1, 2. And we have two ways to get from A to C, two ways to get from C to B. Well, for every two ways A to C, we have two ways to get from C to B, so that's just 2 times 2, which is 4. And so there are 4 of these paths, 4 of these 6 paths pass through point C. And if we take a look at the 6 minus 4 is 2, so that means 2 don't. So if 2 don't, the only 2 that I see that don't pass through C is, I'm going to go with this grid. The only points I see is this path, and if we go like that. Everything else, you cannot avoid the center. That means this technique is working. So we're going to go back to this problem. And, well, if we take a look, we're going to get from A to C and then C to B. So from A to C, we're going to count the number of ways we can do this. Well, we're going to go down once, and then, so D1, and then we're going to go right 1, 2. So again, down once, 1, 2. So this is 3, since 1, and then we have 1, 2, which is 3, and this is just 3 choose 2. 3 minus 2 is 1. This is also 3 choose 1. 3 choose 1 is 3. So A to C is 3. Now we have to compute C to B, which should be equally as easy because it's the exact same distance. So down once, I'm just going to count, and then right 1, 2, which is 3 choose 2 for the right. 3 choose 2 is 3 choose 1. 3 choose 1 is 3. So C to B is 3. For every time we go from A to C, we have 3 more for C to B. That means we just multiply 3 times 3. which is 9. And that means 9 of the 15 paths pass through the center, I guess we call the center, point C, basically. Which means 6 don't. I guess 15 minus 9 is 6. Alright, so yeah, that's another type of problem you may encounter when it comes to combinatorics.